This week on the Agent Factory.
We got the perfect person joining us for that, Ravin Kumar, a researcher on the Google DeepMind team.
So we start with what the user potentially would want or what we want the model to do for users.
This model can actually look at a computer screen, understand what it sees, and then interact with it for you, just like you or I would. Welcome, everyone, to the Agent Factory, the podcast where we go beyond the hype and dive into production-ready AI agents. I'm Amit Maraj.
I'm Nardini, and I'm great to be back, Amit. So today we are going to cover one of the top of mind for anyone who is working in the AI development space. And essentially, we will cover how to build and train an open source model with agentic capabilities.
Exactly, Ivan. And this one's super special. I'm very excited for it because oftentimes when we work with AI, we tend to forget what goes on behind the scenes or how these very important, critical, smart models are actually made. So today we're cracking one open and taking a look at what goes on behind the scenes when developing an open model. We're talking about what the data looks like, the supervised fine-tuning process that's involved, reinforcement learning, and the evaluations, the whole factory line. So this is where the rubber meets the road.
Well said, Amit. So the crucial aspect of agent development, we are going to cover the crucial aspect of agent development, and we have to provide practical insight using, the Google Cloud technology and the broader ecosystem.
Yeah, and we've got the perfect person joining us for that later today. So in the show, we'll be joined by Ravin Kumar, a researcher on the Google DeepMind team who specializes in open models. He's going to walk us through the entire factory line that I just talked about.
Cool. So I can't wait for that. But first, let's get our finger on the pulse with the agent industry pulse. So let's jump in. So, what's new in the world of AI agents?
Busy does not even begin to cover it, Ivan. It feels like we've had a whole quarter worth of updates in just the last couple of weeks.
Oh yeah. So what are the most important news for you? Like the one thing that made you say like, oh, that's pretty cool. It's gonna change things.
Yeah, I think for me, it has to be the new Gemini 2.5 computer use model that Google just came out with. I always continue to go back to think about this model anytime, I see a new release today. So this is the one I feel like I've been waiting for as a programmer for a long time.
Yeah, I saw the headlines and several, colleagues, they built these cool demos of, this magic happening on the screen, things that were get bought by themselves. So can you explain a little bit how it works? Like, it's like a person on a computer?
Yeah, exactly. I mean, it allows me to be even lazier than I am today, which may not be the best thing. But okay, think of it this way. You're giving an AI its own virtual mouse and keyboard. So for so long now, we've had AI agents, obviously, but they've been limited to like structured APIs. Of course, MCP solves this to some degree, but this model can actually look at a computer screen, understand what it sees, and then interact with it for you, just like you or I would. I mean, we're talking clicking buttons, typing into forms, scrolling through pages, all of the good stuff.
Yeah, these seems tasks, that are far away from what we are doing here, like recording a podcast. So I feel like I'm still safe. But can you give me an example, like what kind of application you would build with this capability?
Yeah, you're a great podcast host, Ivan, so you might be in luck. But this is a massive step for building agents, especially for programmers that can do tasks, not just find information. So imagine you had an assistant that can, actually go to a website, log in for you, and then fill out that super complicated form, or just fill out a PDF or something. Google says it's faster and more reliable than other models, and it comes with its own security preventions in place. So you as a programmer can define those, and developers can start building with it right now through AI Studio and Vertex AI.
Cool. So a donor and not just a knower. I like that. And speaking about AI Studio, like you said, the developers can use it there. Wasn't there another bigger update, like something about vibes, I think?
Yeah, you got it. So vibe coding is all the rage now. And yes, AI Studio has joined the party. And so the name is just perfect. It's aimed at removing the most tedious part of building an AI app, which is the blank page, the API wrangling, and how do I even start building this problem? Vibe coding seems to be changing a lot of that by using AI to develop for you, and AI Studio now allows you that capability.
Cool. So how does that work in AI Studio? Like I will assume for sure less boilerplate code, but how is the interaction with it?
Yeah, totally. I mean, it's way less than it used to be. I remember having to develop applications from scratch and having to find boilerplate code somewhere on the web to just get me started. So instead of needing to do any of that, you can just kind of be, juggling 5 different APIs or tasks, and you can now describe the vibe of the app that you want. You literally just type it in, make me an app that takes a photo and turns it into a fantasy character. And AI Studio will use the most recent AI agent or AI model, and then the AI handles all the complicated wiring in the background and develops the entire application for you. So you don't need to focus too much on, writing that detailed, complex code. You can focus on continuing to be creative.
Yeah, that's to be honest, like that sounds very promising, like a dream, But what happens if this vibe, like if something wrong happens? Like, what if it gives me, for example, a purple bottom when I ate purple, or I want another color?
Yeah, I mean, that's the other part, right? You can only describe so much, but if you describe it in an incorrect way that the AI agent doesn't understand, then of course it can go a little bit off the rails. But they did add a new annotation mode. You can just highlight the, purple button on your screen and tell the AI, change this button to green or animate this picture. And, for our YouTube audience, we'll put a little graphic up. It's basically making app development feel like a simple conversation, which is great for opening it up to more people.
Okay, that sounds. I like this, interaction experience. I will say, like, you can immediately change things just selecting in the screen. It sounds pretty cool, and I will assume that it will be an easier way to build apps.
So a new blog post by DeepSeek AI kind of caught my eye. It's been popular quite recently, and it's for their DeepSeek OCR, and it's all about like context compression. Ivan, have you ever like tried to feed 100-page PDF into an LLM and see what happens?
Yeah, I mean, I remember when we launched Gemini and they had that large context window. I was trying to leverage its capabilities to do that. But what I noticed is that the more you add information, the more in general, LLMs tend to forget the information that is contained in these pages. So, and the other problem is because for each pages correspond to tokens, you ended up to pay a lot of money for it. So I'm wondering how this changed things.
Yeah, exactly. That huge bill. And then also like it starts to lose context in the middle of the PDF, depending on how long the context window is, right? But anyways, DeepSeek's solution is to stop feeding the AI just raw text. They use computer vision to almost like take a picture of the document, understanding not just the text, but the 2D layout, the columns, the charts, everything, and then feed that entire context into the model itself.
Okay, so at the end of the day, like you will be able to process the entire content and not just the texting part and creating like the associated output to it. Sounds pretty cool.
Yeah, exactly. And then here's the kicker. It then compresses all that visual information into an insane ratio, turning 10 or even 20 text tokens into a single vision token. The compressed map, as they call it, is then fed into the AI, and they're reporting it's about 10 times faster and 20 times cheaper. It's a completely different approach that could finally solve that long context problem for good, I think.
Okay, that sounds like pretty interesting. So essentially, we are keep moving from just text understanding and trying to leverage also the visual capability of these models. It is a good link to the last topic, which I wanted to cover. Like, what about the videos? I heard there are some news there.
The last big one is the massive update to VO 3.1. So it's Google's AI video model. VO 3 came out earlier this year, and how it's being plugged into filmmaking tools like Flow.
Yeah, I play with Flow, and it's pretty impressive. Like, what's new with VO 3.1?
Yeah, so basically, at the end of the day, it's just more realistic cat videos. But on top of that, obviously, the real news is control. First, it's not just generating silent movies anymore, it's creating rich audio to go along with the video, so that's nice. But then the part that really blew my mind is the new editing features.
What do you mean? Like editing with the prompt or?
No, no, no. Like editing the video after it's been made. There's a new like insert tool. You should check it out. you can just add a new character to the scene just by clicking that button and then telling it exactly what you want it to do. And then the AI figures out all the lighting and the shadows and matches it. And even crazier, you can use like a remove tool. You can just erase something you don't want, and the AI paints the background back like it was never there. So it keeps the entire scene coherent. Then as you introduce new characters and new scenes, it'll flow naturally.
That's insane, by the way. I mean, it's pretty interesting. Now you got my attention. I'm gonna try. I was not aware of it. So it's I mean, the funny thing is that it seems to me that we are moving AI video, from simple text to video capabilities to a more complete and overall editing studio.
Yeah, I think that's the perfect way to put it, right? It's all about giving creators iterative control, not just one shot or nothing roll of the dice. And I think that's kind of what we've seen till this point. We want a more comprehensive, cohesive tool that creators can use to continue being creative, thinking up really cool ideas, and then allowing the tool, the AI, to do the heavy lifting for them.
By the way, you were right at the beginning when you said that we had so many cool things this week, like agents with computer use, AI that you can use to build apps just by coding them, models to read models, and also now these videos that can edit using tools. It's a lot. I mean, it's pretty cool to catch up with these new technologies.
Yeah, it's a lot, but the common thread is that they're all pointing in the same direction. AI is becoming more capable, more visual, and a whole lot more useful.
Okay, that was a great summary. And so that was our agent industry pools. So now we are ready to jump in the next section where we're going to talk about how to build an open model with agentic capabilities.
So we're going to crack open an open model and learn a little bit more about it.
Yeah, so excited to talk about this topic, Amin. And one thing that I'm thinking is that when you build a model, an open model with these new agentic capabilities, like what are the practical challenges that comes to your mind?
I feel like it has to start with the data, and I feel like it's always about the data. I mean, a model that just chats and can respond to you, often we hear are just trained on books and websites, and pretty simply so. But to train an agent that acts and can use tools, I feel like you need a totally different kind of data, right? And I don't know, that's just my initial thought, Ivan, but set the stage for us before we bring in today's insights.
Yeah, no, these are good points. So we are going to talk, as we said, like we are going to talk about the full life cycle to train an open model with agentic capabilities. So we will start to how to gather the data, prepare this data, and then assuming that you start from a base model, we are going to cover some of the most important post-training technique like supervised fine-tuning, reinforcement learning, and also the most important part, how to evaluate an open model that has agentic capabilities. So, and the funny thing is that we are not alone. We are going to unpack all of this with a great, guest that is going to join us.
Yeah, but before we dive deeper, folks, just a quick reminder that all the resources, code snippets, architecture diagrams, and documentation that we're going to be discussing today will all be available in our detailed show notes in the Google Cloud community. So we'll also link relevant agent samples, which is perfect for diving a little bit deeper after the episode.
Sounds good. So as I said, today I'm so excited to have the one of the leading AI research and engineer that build and train open model with agentic capabilities. So please, with me, welcome Ravin Kumar from Google DeepMind.
Thank you both for having me here.
Yeah, welcome, Ravin. We're keen to get your perspective a little bit. Let's jump straight in. So building on my first thought, which is obviously data and the input that you give these open models, what does agent training data actually look like? Are we talking about thought bubbles showing the AI's reasoning, or literal examples of it using a tool like a calculator or a booking API or something like that?
Yeah, it's a good idea to start with the data. And to your point, it looks very different than natural language data. Particularly with agents, you want your data to be structured in a particular format that makes it easy for your computer to interpret, which is different than what you'd want a human to interpret. So we grab a lot of data of computer-to-computer interactions. So Google Cloud has many APIs, for instance. That's a great data set to start saying, hey, if we had an open model call the Google Cloud APIs, what would that look like? And then in particular, we structure it with, again, a specific format. So the inference engines can grab that format and call that API in the background for the user. So then the model can come back later and give a nice natural language response.
So if I understand this correctly, you're essentially modifying the data set so that it comprises of good decisions, right? Okay, so from a developer's perspective, then what are some of the pitfalls here? Is it all created by humans, or are you using some clever tricks like a teacher model, generate examples for a smaller open student model? I know this is often referred to as distillation. So is there some kind of this technique going on?
So we start with what the user potentially would want or what we want the model to do for users. So a good decision really goes back to what is the decision the user would want. Then you have a couple of ways of grabbing that data, right? We'd grab data that's close to what a user would want. Again, if they're using Google Cloud, we would grab data that's similar or exactly like the Google Cloud APIs. And then we also then look at other models that have already learned this. So our Gemini series, for instance, is already a great function calling model, one of the frontier models. So we can use Gemini to help teach smaller open models how to use the Google Cloud APIs really well.
Cool. So if I understood well, at the end, the dataset will be a combination of real-world API calls with a response, and then some synthetic data that you will generate maybe with a bigger model. So okay, so now let's assume that we have built this dataset, right? And I will also assume that you will not start for training a model from scratch. So you already have a open pre-trained model. I think it can be like Gemma, right? So how do you build on top of it? Like which kind of post-training process you implement in order to enable this base open model with agentic capabilities?
Yeah, so that's exactly right. We don't start from scratch with this particular model. We already have a fantastic series of Gemma models that are out there that have great natural language capability. The trick now is how do we then teach our Gemma models to be great at function calling? The first step is supervised fine-tuning. We need to teach the Gemma models this very specific format. Again, we need this specific format so a computer can interpret the function call differently than a human, which can deal with a little bit of variability. So supervised fine-tuning is the first and obvious step for us to teach a Gemma model what that format is.
Very cool. Okay, so pretty ingenious to use a model that you've already developed to, generate synthetic data, which is not really synthetic because it's trained on real data to generate data as input for a smaller model. But I feel like this can't alone be enough, right? I mean, it only knows examples that it's seen. What happens when it tries, something new? Like, there's no perfect playbook for an answer in that case, right? I assume this is where reinforcement learning comes into play.
Yeah, that's exactly right. So we want our models to generalize, right? We want our models to do more than just what they've seen. There's so many interesting APIs and use cases, and the world is evolving. So our models shouldn't be stuck in time. And reinforcement learning is one of these training techniques that let the model, like quote unquote, explore and try new things outside of just the data set that we presented during supervised fine tuning.
I would assume that, as we were saying, like we have this data set, it has several, information related to how the model should call the API. So you can have a single API call, you can have a set of APIs that is going to call. So this concept of trajectory, how do you, based on this data set, how you implement the rewarding policy in a reinforcement learning, step like the one that you are talking about?
Yeah, this is one of the most critical parts of reinforcement learning. I mean, there's a couple different approaches, right? If you can think of an agentic flow, the model makes a function call and then gets a response. It then needs to maybe respond in natural language or ask a follow-up. It takes a series of steps more than just outputting one particular generation or one output. So there's a couple of approaches, right? You could try rewarding it only for completing the entire task successfully. You also could reward it for intermediate steps. But if you just pick one of those approaches, they have some pitfalls or downfalls. So let's take the case where you reward the model only for completing an entire trajectory. At the beginning, the model may not know how to do that at all. It may stumble around and it may never get to that final reward. So in that case, the model would really learn nothing because it's never seeing a reward. On the other case, then you may say, let's give it some guidance by giving rewards on intermediate steps. So if we're booking a trip, say, to Paris, if it gets to the travel page, we give it a reward. But the model may then learn just to only get to the travel page and never finish the entire trajectory, something that's called reward hacking. So really, it takes a combination of both these approaches often. And maybe a progressive reward design where we start teaching the model to start making the early steps well and giving it some rewards there, and later only start rewarding it when it finishes the final trajectory. But this is quite tricky, and it takes a lot of time for us to design these reward correctly. And I will tell you from experience, during training, we're watching these reward charts quite closely to make sure it's picking up the right behaviors at the right time, so it can finally end up being this great model that can make all the steps that you need it to do the task that you've asked it to.
Okay, so we've got a trained model using these fantastic techniques, and that's great. But how do you know if that trained model is of any use or if it's any good? This seems much higher stakes because an agent can obviously take a wrong action. Like you said, maybe they don't actually book that trip to Paris, but they just go to the page and they continue, or maybe don't even go to that page, right? So how do you evaluate the capability of a model that you've trained ethically on being able to, make the correct approaches? What does that final exam look like?
Yeah, so it looks like a combination of, as you named, evaluation. So we see the reward going up during training, like that's a good indication that the model is learning what we want it to learn, but we really then have to grade it at the end outside of training. So we can use things like standard benchmarks. There's a couple of these that have already been published by third parties, and we can see how our model performs on those benchmarks. But at Google, we like to go far beyond benchmarks. We really want to make sure the user is going to be happy and that they're going to have a great experience. So we spend a lot of time making user-focused evals for what we think folks that come to Google would expect from a Google model, and folks that are Google users would want from a model that we produce. So a considerable amount of time is spent making internal evaluation sets based off of things that you see from cloud customers, from customers across different areas of Google. And then the last but most important things is we are our own users of our models. You too have been playing around with these models before they were released, and you were vibe checking them. You're building your own applications, and it's really ultimately your feedback that ends up becoming one of the most important components. Because if you're not happy with the models, like why would our users be happy? So all these internal testing that we do by building internal applications and internal demos is a big component of us knowing of whether all these steps of data curation and supervised fine tuning and reinforcement learning reward design all led to something that users would ultimately be happy with.
No, I'm really interested on this aspect because we were having another episode where we talk about how benchmarks, they have their own limits. For example, they use these synthetic data that usually they don't consider aspects of when an LLM or an agent, it goes to production, So they're usually benchmarks that are designed in an academic environment, and usually they don't reflect what are the real world, scenarios. And these implies some limitations when you run evaluation. So the fact that, we combine benchmark with, real user experience, so data that we collect from people that interact with this model is it's a critical point, I would say.
Really cool. Okay, so Ravin, thank you so much. It's been so insightful to open an open model and see exactly what happens behind the scenes. So, okay, just to recap for everyone, it seems like the process for building one of these open models with agentic capabilities comes down to 3 stages. So, first is the data. It's obviously not text as we've spoken about, but complex trajectories. It's kind of like the model's thoughts and actions. And second is the training. So, it seems to be a hybrid 2-phase approach where we have supervised fine tuning to learn these kind of textbook examples, and then we follow that up with reinforcement learning. We let the model kind of learn by doing in the real world, guided by a reward model where we have tons of these different rewards and we're trying to make sure they're being approached adequately. And then finally, the evaluation. So this is kind of the high stakes part, and it's not a simple quiz, but as mentioned, it's like a sandbox obstacle course, and there's a lot of different testing, vibe checking, and different users using it in real life scenarios to see how well it works. And this kind of tests its capability and, most importantly, safety.
Yeah, you get it. You summarized pretty well the entire process, and this it's just some way to thank you, Ravin. It was great to have you here and learning a little bit more about the process of building an open model with agentic capabilities.
Absolutely my pleasure to be here. Thank you both for inviting me.
And that's a wrap from the Agent Factory. Hopefully you've got some new ideas for your next project. A massive thank you to our brilliant guest, Ravin Kumar. Ivan, it's always a pleasure architecting these discussions with you.
Likewise, and to all our listeners and viewers, keep building, keep innovating, try these new technologies that we share with you today in order to bring, more solid agents and put them in production.
Until then, keep your code clean and your agents smart. My name is Amit Maraj.
I'm Nardini.
Powering
Powering down.